Okay, this video covers lab sheet 13. We're looking at the fuel injectors, the electronic side of the fuel injectors. What we're going to end up doing is measuring the resistance of the individual fuel injectors. We're going to take that resistance reading, we're going to compare it to specifications, and we're going to compare the injectors to each other. They should meet specifications, and they should also be really close to one another as well. We want them to be balanced electronically. This is just the electronic side of the injector. We're going to be looking at the mechanical side of it in another lab sheet where we get into the injector balance testing. That'll be a different video, different lab sheet. So taking a look at this, first thing we want to do is talk about what the injector is. An injector is just a valve that's controlled by a magnet. So if I look at this, I've got on one side my fuel will come in, so I got my pressurized fuel coming in on this side here. In the middle, I've got a coil of wire, and then I've got a valve on the other end. The coil of wire is going to be used to generate a magnet. That magnet is going to open up the valve and allow the pressurized fuel to spray through. So in the heart of this, right here in the center, we've got a magnet created by a coil of wire. Now, if I look at this, we'll see if we can get this to show up. If I look inside there, I can see I've got two terminals. Each one of those terminals is attached to opposite end of the coil of wire. So I come in on one side, I go all the way around, wrap around thousands of times, and I come out the other side with my two terminals there. I can go in with a meter and I can measure the resistance of that coil of wire at those terminals. And that will give me an idea of how well the injector is going to be able to operate electronically. So looking at it as far as a diagram, I'm going to zoom in on our handy dandy whiteboard here. Again, we're going to see that we're just dealing with a coil of wire. So I've got a coil of wire, and what's going to happen is we're going to send battery positive to that coil of wire. Anytime the key is on, the engine is running, we're going to have battery positive coming to one side of the coil of wire. The other side of the coil of wire is going to be connected to the PCM to supply ground. So this side is going to have a switch that's going to go to ground. And again, that's in the PCM. So we're going to have that in the PCM. That's called the injector driver. So that switch is actually called an injector driver. It's just a heavy duty transistor and it supplies ground. So I got battery positive. I'm going through right now. My switch is open. No current flowing through, no magnet. When the computer determines it's time to turn on that fuel injector, it's going to close the switch. So that switch will close. Now we have current flowing through here that's going to generate a magnet, and that magnet is going to take and it's going to pull up on our valve and allow fuel to flow into the intake manifold. When we no longer need any more fuel, it's time to turn the injector off. All the computer does is open that switch. When we open that switch, the magnet collapses, the valve closes, the valve closes, and it shuts off the fuel injection. So it's a very simple process as far as theoretical. Again, if that coil of wire is bad, the injector is not going to work properly. If the coil of wire is broken, the injector is not going to turn on. We're going to get no magnet, it won't turn on. If the injector is shorted, we're not going to get a strong enough magnet. So the injector is not going to open up enough, we're not going to get enough fuel. So we have to check the resistance of this whenever we suspect we have a bad injector. So a resistance test is going to be one of the tests that we're going to do. Now I've taken a fuel rail, brought it inside here because it's a little cold this morning. I don't want to be out in my garage with no heat. So I brought in a fuel rail so that we can take a look at it here. Now, we're going to use this for our lab sheet, but I'm going to tell you right now, this is not the fuel rail out of a Chevy Cruze. The lab sheet is set up for a 2012 Chevy Cruze with a 1.8 liter engine. That's what I want you to look the information up for. Using ShopKey, all data, look up the information for that 2012 Chevy Cruze. I gave you a note on Blackboard telling you how to access all data in ShopKey, so you should be able to do that. If you have any problems, shoot me an email so we can get it straightened out. So what we're going to do is we're going to measure the resistance of these injectors. We're going to go through injector 1, 2, 3, and 4, measure the resistance, and see what our resistance is, compare it to specs, and compare it to the other injectors. So we're going to take our meter. We're going to set it up to measure resistance. Once we have it set up to measure resistance, we're going to verify the condition of our meter. So I'm going to take my 2 meter leads, I'm going to put them together, and I'm going to look at my meter reading. When I do this, I see that I've got a reading of 0.2 on my meter. I have to take that into account. That's the internal resistance of the wires and the meter itself. When I measure the resistance of the injectors, it's going to be a relatively low number, and the resistance of that meter can throw it off. So I want to take my injector resistance readings and I want to factor in that resistance of the meter itself. So I'm going to go to my injector number 1, and I'm going to hook up to the 2 terminals in the injector, and I'm going to get my reading. All right, so I've got 12.5 ohms of resistance there. Now, keeping in mind, 0.2 of those ohms is from the meter, so really my injector is 12.3. So that's what I'm going to write down. Then I'm going to go to my injector 2. I'm going to take my reading. And you can see the reading on the meter there. I want you to write that down. It's injector number 2. We've got our reading there. Injector 3. We can see our reading. I want you to write that down. And then number 4, we get our reading. And again, write that down. You're going to take those readings, get them all written down, injectors 1 through 4. You're going to compare those readings to specifications and compare them to one another. They should be relatively equal. Hopefully you picked up on something here. Now again, these are not the injectors out of a Chevy Cruze, but I want you to compare these numbers to those specs for the Chevy Cruze injector. The next thing we're going to look at is the wires. So I ask you to look up the wire colors, and you'll see that I gave you just one line for the power wires. Then we got the individual ground wires. I want you to write down the color of the individual ground wires. On the lab sheet, you'll have one line for the power wires, and you'll have 4 lines for the ground colors. You're going to write those down. When you do this, you're going to see that the wires will be common. One wire will be common for all 4 injectors. So when I look at the wiring harness on this one, I can see that my wires coming to this injector number 1, I have a green wire with a black tracer, and I have a blue wire with a black tracer. So I've got 2 different colored wires coming here. When I go to injector 2, I see that I've got a green wire with a black tracer and a yellow wire. Injector 3, I've got a green wire with a black tracer and a white wire. Injector 4, I've got a green wire with a black tracer and a white wire with a black tracer. So all 4 injectors have a green wire with a black tracer. That's our power wire. It's going to be a common power. Then I look at the individual ground wires and I see that they're all different. They're all going to go back to the PCM. They'll have different colors coming in, and the computer is going to control the injectors separately via those 4 different wires. Again, you're looking up the information for the Chevy Cruze. The wires will be a different color than the ones I'm showing you here. This is just an example. So you're going to look up that information, write it down, And then when you're working on the car, you would actually look and you'd be able to identify which wire is which for each injector by looking at the color of the wire themselves. Then the last thing on the lab sheet is I just ask you to indicate to me how the injector is turned on and off. Basically, you're repeating what we've done here in the lab. All right, this isn't meant to be rocket science. We're just looking at understanding the operation of the injector, power, ground, how the computer controls it. All right, use the wiring diagram for the Chevy Cruze to inform your answer. How does the power get to the injector? Then how does the computer control the ground? I only give you 3 lines on the lab sheet, so I'm not looking for in-depth information, but I am looking for solid, succinct information. When you're done, save the lab sheet as a Word document. Email me a copy of the document to my Hudson Valley address, preferably using your Hudson Valley address. It's just easier for me to open the documents that way. So that's the lab sheet for this time. Be well.